So let us see how we handle this question. It's still now about a product, propagation of errors in the product, but now here we have x squared and y squared. So now, what they tell you to be your approximate value. So some questions, they'll give this as capital X as the approximate value. So always concentrate on the question you're handling. So the question is like that. So it's the one that the maximum item error is given by this. So you know that always error is given by exact minus approximate. How exact was this approximate? If you make the exact sum, you take this side, you get that. Also take this side, you get that. So the error in this is going to be the exact product minus the approximate product. So the exact is this, the approximate is this. Now, here is that we don't have anything like root. Whenever I have a root, we shall see how we handle it. What you do first, remove that root by squaring both sides. So if you don't have a root, you do it the way we have been doing them. So now we remove this exact and then we put in the approximate. So here, so that's what we are having there. And then expanding. When we expand this, we get this. Then this is there. Then we multiply this and this. This is what we get. Then minus that. So now this is going to be going away with that. And this one that also x squared, this approximates 0. Then also is that also this one, delta x, delta y, also approximates 0. And so because they are very small, so if something small by something small, we get even something more small. So our error in x squared y is going to be now, we have this as x squared, sigma y, then plus, this is 2xy, then this is going to 0, also this is going to 0, what else? And also this is going to 0, so that's what we are making with. So now, from here, you can get the absolute error if you want, but now, we are interested in getting the maximum relative error. So this is now the error. If you want the absolute value, you can get the absolute value of this, then. So now, to get now the relative error, our relative error is going to be given by the error, which is divided by now the value. Now here we are dividing with the approximate value. Why? Because we are always given the approximate value. Because if we know the exact value, then there's no need of giving us an approximate value. So we always divide with the approximate values because they are the ones we know. So that's why I'm going to divide here with the approximate, our approximate, which is x squared y. Because always when you measure something, you get the approximate. So what you have immediately is the approximate, not the exact. That's why I'm dividing with the approximate value there. Okay, so what happens? I'll get now, when I have here now, this will be, now I'll get my this, which is x squared, then plus 2xy, sigma x, the whole divided by x squared y. Then from here, I said you can separate. Then plus. So there we are separating, just there's not anything big. But this one goes with this one x goes with this, then this y goes with this. So that this is going to give us sigma y over y, then plus 2 what is that? 2 sigma x all over x. So from there, we introduce, so we want to get now the maximum. This one, the order of this is given, is equaling to e x squared y over x squared y. So if we introduce now the modulus both sides, so we'll be equaling to modulus of this. Now I will start with this here. And we say now this will be the same as Now if we separate, this is going to be now 2 sigma x over y. And say, if this is less or equal to this, and this is equal to this, means that this is also less or equal to this. So now E now, if you want the maximum, this one in smaller, this means that this, the error we can get is less or equal to this. Now, if you want the maximum error we can get, the error we can get to be maximum is when the whole of this is equaling now to, that is that thing of equaling to, when I cover it. If you want those which are less, that's what we get. But if you want the maximum, then that is what we shall be having. The maximum, you cover that. You see that the maximum we can get is when the whole of this is equaling to that. So now, my E, the max of it is when it's equaling to, remember this 2, we can take it out because it's already positive. So, and so that will be our proof as you see it there. So this is the maximum relative error. So remember the whole of this is relative. So our RP mass is equal to 2 over y. That will be our mass. Note, why are we getting this here? Note that when you have 2 m modulus, this will be the same as modulus. In simple terms, this will be the same as modulus of 2 times modulus of m. This will be the same as 2 m. In simple terms, you can get it as 2 m like that. Because modulus of m modulus of t is 2, and also modulus of m is m. As simple as that. So, those are the tricks we are using here. That's why I was able to get this from here, because it was a product. So, it was a product, then you bring out this constant. There. So that's it, members. Why are we leaving now the errors in modulus? Because sometimes these errors, for them, are negative, they are negative, but a positive 2 is a positive 2. So whenever you get a negative error, that's why you can put them, because I think we have seen when they are giving us approximate values which are negative. So that's why for them we leave them in modulus signs. So that's how we shall get that. So that's it, members. We are going to see some questions there.